And welcome to the Industry 4 Community Podcast. I'm your host with the most, Walker D. Reynolds. Man, you know, that opening never gets old. I'm just going to be honest with you. I don't think that ever gets old, and I'll probably never get rid of it. All right, today, the conversation. Speed is becoming more and more important. For years and years in the Industry 4 world, real time was defined as every second. If we could get it down to 1 second, that's real time. That is, if we're collecting data in real time at 1 second interval, that's real time. Inductive automation, for example, in the old days, their default scan class was 5 seconds. So real time to inductive automation for years and years and years was every 5 seconds. In the UNS world, I used to say, you know, as long as you don't need to collect the data faster than every half second, you're real time. You're good with UNS. However, we are entering a world where that is no longer sufficient. And so this conversation is about the technology that closes that gap. And it was serendipity. It was God putting me in the right place at the right time to come across this tech. Right about the same time I was introduced to AnyLog, which I know fills a whole other gap in the industry that has been created, or at least the flashlight's been shined on these gaps in the post-agentic AI world. They were not important prior to GPT, or they weren't broadly important. And so the conversation today is all about, well, one part of that discussion, which is speed is now important, much more important than it was. The definition of real time is changing, and it is changing drastically, and it needs to. Because if we really want to unlock the potential of agentic AI, then we're going to have to, what we call real time is going to have to change drastically. And so this conversation is about that theme and that model, but in the context of technology that closes that gap, which is DADOS tech. If you guys have heard me talk about them a million times since Prove It, really since January, where I was introduced to DADOS in Miami, I think. Yeah, I was in Miami. Manny came and visited me while I was speaking at HiveMQ. I did a deep dive on the tech. They were already coming to Prove It. And then they basically landed at Prove It and dropped a bomb on everybody. So this whole conversation is around that. We have Ken and Luke Gardner. I'm going to let them introduce themselves here in a second. But before we do that, I want to go through the announcements because, you know, I'll get yelled at if I don't. So let's go through our announcements here. All right. So real quick, we're going to call this episode Creating the Fastest Data Retrieval System for Industry 4 and 5. We're actually going to talk about Industry 5 here in a second. But community announcements. All right. Number one, Masterminds this Friday at 9. We're going to be going over ERP, UNS ERP in the age of agentic AI. I have a delightful lesson for you planned. I'm going to be shooting the second video in this series, which was why does this all matter? And I'm going to be showing you how to expand knowledge graphs using user edge relationships to do deeper analytics on our data infrastructure. Things like being able to answer questions like, where do I invest my next $1 million? Or which of my assets do I sunset? Or which of my vendors are underperforming? Okay, my raw material vendors. I'm going to be showing that in the second video, and the core of that lesson is going to be part of what I teach in Mastermind on Friday. Those of you who are asking about UNS Studio Beta, you guys will all be receiving emails. We're ready. We just did the final release candidate. You can sign up for the closed beta right now. I think there's 200-something people who are going to be doing the beta on UNS Studio. those of you who have asked me what is UNS Studio, I don't know how to describe it. There's not anything like it. I basically built the toolkit. The closest thing would be it's an information platform. It's it does connect, collect, store, analyze, visualize, find patterns, report, and solve. It does the whole stack, but it's not an IIoT platform because it's not meant to write back to process control. There's no drivers like device drivers. It's consuming from IT protocols, which we assume it's already been transformed. We also have the product that you guys may have seen in the video I shot. Why does this all matter? Everyone keeps asking me what was the product that I was using to do my demo. That's Notice. That's another product that we've developed, which is kind of like a combination of Lucidchart and OneNote with a bunch of Industry 4 tools. And basically the canvas becomes the agent context. And I'll be talking a lot more about that later. DTMA scoring app. Those of you who are in Mastermind, you should have received access to the DTMA scoring app where you can do self-scoring on digital transformation maturity assessments. That is in like an internal closed beta with the community, but that will be made available public for those of you who keep asking. And then last but not least, our workshop next week, Dylan Dufresne and I are doing where to start in digital transformation for the manufacturer. You can go to iot.university and sign up for that. If you're in Mastermind, you have to opt in. I think we're at 170 something students in that workshop now. It's crazy. I think it's going to end up being our largest workshop, which is fascinating. I just had this conversation yesterday, which is fascinating. The market wants to sell to the end users all of this advanced technology. Like everyone's going to market with all this advanced stuff that only nerds are excited about. Like, and I'm a nerd. I'm excited about it. But the end users are still asking, where do I start? But where do I start with digital transformation? That's this workshop. Okay. So Tuesday, Dylan from Abelard and I, it'll be 4 hours on Tuesday. We're going to be walking through the process of where to start in digital transformation. So that's inventory the business, inventory the intelligence, build your infrastructure, define your digital strategy, architecture, minimum technical requirements, choose your use cases, your POCs. How do you decide to do this one? What should our window be? When should I expect ROI? All that kind of shit. And then on Wednesday, we're actually going to be doing the technical lesson featuring a virtual factory. And we're going to do the connect, collect, store, analyze, visualize that we learned about on day one. Okay. If you're in Mastermind, that's already included. If you want to sign up for the workshop, you can. There's a QR code on there. And let me start with this before I introduce Ken and Luke. We recently entered into a strategic partnership. Okay. So Datos is the very first company that I have entered into a formal advisement partnership with. Companies have been asking me to do this for years and years and years, and I always say no. And there are two companies I've entered into this partnership with. And I don't need to tell you who the other one is. It's Anylog and it's Datos. And the reason why is because the technology from both is revolutionary. Both of their technology is revolutionary. There are gaps in the market that must be filled in order for us to realize the promise of Industry 5. Datos is uniquely positioned to fill it. They also meet all the requirements of a software company that will survive the post-agentic AI world. Okay, you're not going to be able to just recreate Datos. Okay, you're not going to be able to build it yourself. You're not going to be able to build Lightning or Flow yourself, nor would you want to. Same thing with Anylog. So we have entered into a partnership. Okay. I'm not an employee. Obviously, I still own Intel 4.0 Solutions and I work at 4.0. I'm not compensated to promote them. They're not paying me cash or anything, but I am a formal strategic partner with them. Okay. I'm not on the payroll as a salesperson. I'm not, none of those kinds of things. I've evaluated the technology the same way I evaluate everything that comes through 4.0 Solutions. And I chose to partner because I believe what they build fills a real gap in the space. And a gap we have to fill fast. And we're going to make the argument for why today. This podcast is not because of that partnership. This was already previously planned. So treat this conversation between people who've worked the problem. It's not a sales pitch. Okay. All right. With that, let's introduce Ken and Luke. So, Ken, Luke, for folks who haven't met you, walk me through your backgrounds. Ken, specifically, what did you do before DADOS? And what was the moment you decided that this needed to exist? Why don't we do the intros?
First, let me just, this is a father-son partnership. It's been a real joy to work with Luke, although we argue like madmen.
Nice. Sounds like me and Josh.
All the time. Yeah. So I'm a 7-time company founder. I got out of college in 1972 and got hired as a programmer trainee.
Where'd you go to school? Where'd you go? Everyone's going to want to know where you went to school.
University of Louisville, next year's #1 basketball team.
So does that make you a Raven? Does that make you a Baltimore Ravens fan?
Cardinal. It actually does. Yes. Okay. But not every day. So 7 times. So I got out of college and I got hired as a programmer trainee. I won't take you down that rat hole, but I loved it. I told my father, I said, this is what I was born to do. And the truth is, I love building software. And I love building it, especially from the beginning. And I've been very, very fortunate across my early career to almost always work on the brand new project. Banks in the 70s were converting from punch card systems to mainframe. And so everything had to be rewritten.
To go off the beaten path, just a slight, I think if you were going to summarize in a couple of sentences or less how programming has changed from the moment you came out of college to today, and I get it that, Luke is the CTO and he's writing the bulk of the code, but if you were going to describe how programming has fundamentally changed in a couple of sentences or less from 72 to now.
I think Luke has it a whole lot easier than I did. So, and let me just explain why. So the first mainframe I worked on was a 36040 that had 12K of memory, and 4 of those K were taken by the operating system, DOS, which was one of the IBM operating systems. So you had 8K. And so in that era, everything was tape to tape. Mm-hmm. You could use a disk, but only for sorting. Programs were written in COBOL. And then when you ran into performance problems, you had to go down into IBM Assembler, which I was actually pretty good at. And that ends up being a theme, because over and over and over again across the years, you run into a performance problem and you have to go underneath whatever tool you're using in order to be able to get past that performance.
Yeah, and it's crazy. Like, you guys understood. Like, I've never spent a lot of time trying to understand machine language or assembly. I mean, I understand it, but I've never taken the time to deeply understand like assembly or machine language. And you guys had to know it intimately.
You had to know it cold. So if your program crashed, you got called into the bank in the middle of the night, usually about 1 or 2 in the morning, and they handed you 100-page hex core dump, and you had to go through that and figure out what had happened, what the mistake was, how to patch it so you could get home.
And no AI to point out where the error was.
Correct.
And no AI for sure. Well, we didn't even have
using LEDs.
There were no performance monitors, which I think one of the things that we've used the hell out of this year is performance monitors, where you monitor every single thing about it to find all of the places where you can remove time. And so this was, now you were writing pretty low level stuff. So you didn't have to, and the programs were, you would take your checking account system and you'd break it into, I think it had 10 steps, because each step had to fit in 8K. So the primary architectural construct of that era was You had to fit in memory.
Wait, you know what's really crazy is it's very in many ways. Well, we're really going into the weeds here. The nerds are loving this. The nerds are loving this.
Right.
Here's an interesting thing. In the world of the post-agentic AI world, we're coming full circle. Okay.
Yeah.
Because guess what we all do? We're all managing. It's not down to 8K, but we're managing context in each turn.
Yep.
In exactly the same way that you were managing memory in each instruction.
Well, it's a good foundation, and there's a discipline to it, because if you mess up, you're in the bank in the middle of the night,
right?
In a bad part of town. So,
all right, before we go to Luke, what is a product in your previous 7 iterations? What's a product that our community would likely be familiar with?
You might be familiar with Sagent technology. Sagent and Informatica were the very first 2 ETL products that launched in the product. It's ironic. We were within 2 blocks of each other. We were founded within 2 months of each other, and we went public within 2 weeks of each other.
So ETL was your big domain for a while.
For quite a while. Yeah.
I mean, that explains why you guys would be the ones to develop Datos.
And then after that, in the early 2000s, I built a product called Estante Systems. Estante was in 2001, a real-time or near real-time dashboard system. We would change data capture from transaction systems and then display the results of that on a dashboard. That is still shipping today. We were bought by PeopleSoft, which was bought by Oracle, and it is an Oracle product called Oracle BAM.
All right, so Luke, to you, for people who don't know you, what's your background? But when you get to the end of your story, do me a favor and explain how you arrived at building a real-time analytics platform that was originally for the Apple Vision Pro, which, by the way, that is the origin story of Datos Tech. This technology was originally being developed for the Apple Vision Pro. Okay, so end your story, Luke, with how you ended up developing this tech for real-time analytics for the Apple Vision Pro that ultimately led to Datos Tech, which is an Industry 4, Industry 5 tool.
Yeah, so I went to college at Worcester Polytechnic. Before that, even before college, I was lucky enough to have a father who worked in the industry. And so I got summer internships going all the way back to high school, getting to work in tech. As soon as Ken had me sit down and actually try and learn programming, I loved the puzzle of it.
First off, do people think it's weird that you call your dad Ken? Because by the way, my kids who work in my companies, they call me by my first name. Yeah. And everyone thinks it's weird when they know they're my kid. Does anyone think it's weird when you do it?
It gets real weird in a stand-up meeting where he's three layers of management above you in the company to call him dad. And so I for a while, I just called him KG, and then, that becomes interchangeable.
Okay. Now it's knowledge graph. That the irony, you saw the comment in there that what was it? AI agents go to Ken for the answer.
Yeah.
Somebody wrote that how ironic that it's KG, Ken Gardner, and KG is also the abbreviation for knowledge graph. Ooh, that's eerie, man.
It tickles me every time I see it.
All right, go ahead, Luke. Sorry.
But so got lucky enough to do summer internships and part-time all the way through college at Ken's companies. And then joined and worked for 1 month as a data visualization engineer at the low level. And then Ken threw me right into, hey, this part of this system isn't working right. Go lead a team of 3 and go fix it. And that was at the time our data engineering system. So I've been lucky enough to work data visualization, data science, data engineering, do full stack for web apps and native apps.
Did you study computer science? Is that your?
Yeah, computer science was my.
And you focused on software, not hardware.
Yeah, just I wasn't exposed to it, right? Until deep into college, junior year or something. I took a electrical engineering class, but that was where it was cool, but I was already deep into the software world.
Are you an only child? I don't know Ken's kids.
I'm an eldest. I'm an eldest child, but
are you how many siblings have you got?
2 younger. Yeah.
All right, let me ask you this. All right, because I have 4 kids,
Mm-hmm.
and only one of my kids is an engineer like me. That's my son Jared. All of my kids have dabbled. My youngest son is studying nuclear engineering, so he'll end up being an engineer, but not what I do. Just because we have the same DNA doesn't mean our brains operate the same way, right? So, dude, so it's kind of it's unique that you actually, I mean, because you're a very gifted engineer. I mean, I've seen your work.
Well, and I've got some really gifted engineers on my team as well. But yes, it's been a really, really fun time. Ken always
have your siblings. Do your siblings have the gift, or did you just get lucky?
Begrudgingly, my younger brother is way smarter than me.
Okay, all right. Man, you did good, man. Ken,
Yeah.
you did real good, buddy.
Oh, thank you.
All right, so the Datos tech. Do me a favor. So that when we originally met, because we're going to answer the question, what is Datos and why does this real-time thing matter right now? And we're going to talk about some of the benchmarks and what form Datos takes. And, it's basically 4 elements altogether, but there's 2 that really matter. It's flow and lightning, and how do they work together, and what are the applications in industry? But I think this origin story matters. Like, why is it Datos developed this tech and someone else didn't? And the answer is because you were developing it for Apple, and it was going to essentially be the plane in the operating system that was moving data from one place to another in the Apple Vision Pro. And it had to be as performant as it possibly gets. Like, it has to be as fast as humanly possible. And you had to figure out a way to overcome that challenge. How did you guys land? Where did that come from?
Well, as soon as Apple announced, so my whole career, if you look at every company I've started, it's been based on some technology change underneath that enabled something new, right? So the Apple Vision Pro, you could have an infinite number of widgets open, and you could do all sorts of really fun things in order to make sure that this is important. Pay attention to it. And we actually had that product ready to go when it became apparent that Apple was not going to make a commercial success.
Yeah, it's too heavy, too expensive. At the end of the day, it had nothing to do with the technology.
I agree.
The tech is amazing.
Yeah.
It's too heavy.
It will reemerge someday,
right?
As glasses.
Yes.
In my mind, I remember I told the Apple evangelist, this needs to be like the glasses you used in biology in high school. It needs to be about that weight. It needs to, not look stupid on your face.
Yeah.
So in March,
people walking around the streets wearing their Vision Pro, and they look.
Oh, I know. Yeah. Well, people actually did that. That was crazy. Yeah. So so my background is data. Every company I've done has been a data company, and this looked like the ultimate user interface for complicated data analytics. Yeah. So March of 25, it became clear that they weren't going to reach commercial success. Now, they wouldn't tell us that. They wouldn't tell the developers that. They would never do that.
Right. Because you guys would all get abandoned before they made their decision.
Right. And so they kind of announced recently that, okay, so we're gonna continue forward, but I think that they're really working on is the software, which is amazing. So we looked at what we were doing. So now we have a data server with nothing in front of it.
Right.
And so, believe me, as an entrepreneur, you're now in the data server business. So we went out and we had conversations with a number of companies. We talked to Salesforce, which was beginning Agentforce at that point.
Yep.
We talked to some wealth management firms, and everybody at that point, the early agents were customer service agents. And what all of those companies decided was, well, the end users don't need real-time performance.
Yeah, they don't need speed. They don't care about the end user.
Well, that's right. The 10 seconds is fine. They'll wait.
They can wait.
They want their bank balance.
Yes.
So
They can wait.
At that point, we started publishing benchmarks.
All right, real quick, before we're going to get into benchmarks right now. So before we get into benchmarks, Luke, explain what Datos tech is. And by what I mean is, imagine the reference architecture for what makes up what we refer to as Datos tech, and explain it as a flow diagram, here to here to here to here.
Yeah. So we start at we start at the devices, but really for us, we start at the broker. So your devices are sending all your messages to the broker. We have Flow. Flow attaches as a subscriber to the broker. And really, it's many subscribers. We love the shared subscriber system in MQTT, so take advantage of that. And Flow is responsible for, as we've gone through, we come out of the data world, and so we wanted to get out of messages and over into analytics systems as fast as possible. So Flow is responsible for translating those messages into an analytics format called Apache Arrow, which is the best in-memory data analytics format that you can get at the moment. And that piece of Flow, that translation, catch the volume, translate all of that volume in real time. We've gone out, have a patent pending on that. And that is the key piece that allows us to attach into the existing systems.
And you're using Sparkplug by default, right?
Yeah, certainly prefer Sparkplug. Sparkplug provides a lot more structure to attach onto, which means that you can go faster.
You're not required to use Sparkplug, although that's the default.
Yes,
right.
Yes.
Okay. But you do take a performance hit if you move away from Sparkplug.
if you're doing raw JSON instead, you take a performance hit, and you take a data schema hit as well.
So Flow converts the messages into Arrow.
Yes.
Okay. And then when do we move from in memory?
Really important.
Right. In memory. We're not writing to disk. We're in memory.
In memory in the live process. You're then sending that arrow to Lightning Plus, which is the data server.
So, and those of you who are listening, I want you to imagine. So basically, an implementation of Datos tech is deployed in containers. So
yes,
Flow is running in a container. Lightning is running in a container, and then you have YAML files that are defining all the connections and all that kind of stuff. Okay. So if you want to know the form. Okay. When we go from Arrow in memory in Flow, what happens when we get over to Lightning?
So Lightning is the data server. It's responsible for serving the query requests as fast as possible.
Yep.
But we think it's really, really important that data server is a full SQL engine. So it's not a cache. It's not a key value, lookup system where you're reliant on, the question already having been asked or priming the pump or any of that kind of stuff. It's full SQL queries so that when your agentic systems come and ask, they can change the query a little bit and get the exact thing they need, and drive all of that speed through the data request.
So ingress are events, messages from from the broker. Okay, that's ingress.
Ideally in a UNS that's already set up. Yeah,
correct. And then egress is what?
Egress is via an API, and you can do API direct. We also have a library that will wrap the API for you and do the transmission in the most efficient manner.
And how fast? How many messages? How fast? This is crazy. These numbers are fucking nuts.
So it's recent performance test. This is the most recent one I've got. So we ran a 30-minute test. We took the data from Prove It, and we multiplied the Prove It data stream by 3,000 times. Sent that through 5 brokers, 1 Flow, 1 Lightning. So that's 1 million metrics a second, and it is a ingestion P9999 of 3.8 milliseconds. So that's the latency on ingestion, and then the queries going out the other end in the live system is a P49s again of 5.3 milliseconds.
So now what we're doing is we're getting into the field bus range. Like in memory, we're getting ingestion rates and speeds that we see in field bus, but in memory.
That's right.
Like like clearly the choke point is the message through the broker now.
Yeah, I mean we've seen the brokers can go really, really fast.
Yes, they can
in our testing.
Yes, they can.
And that ingestion latency that I'm quoting there includes the broker time.
Okay. All right. So now we've established what flow is. All right, Ken, back to you.
Okay.
So now we've established what flow is.
Okay. So in after Salesforce turned us down.
Yes.
Not that politely, by the way. We were approached by a message broker company, somebody you know pretty well.
Yeah.
They had a specific problem. Could we process millions to tens of millions of Sparkplug messages a second during ingestion, then query that data with low latency? And we said, interesting. Okay. So
everyone should know why they were asking that question. I mean, anybody on this should know why they were asking this question.
Yeah. And so what our answer was, maybe give us 2 weeks and we'll tell you. So 2 weeks we came back and said, yeah, we can do this. Right. In fact, here's most of it running right now. What's different about that problem is the performance is mandatory. You cannot work in the control window. You're out. You go away. And so that put us in the situation where if we can make this work and make it work really well, for some time we would be the only company in that category.
So here's where, when I looked at Datos initially, because I want to get into the strategic frame of real-time data, like why we have to redefine what we mean when we say real-time. So when we talk, let's set a couple of definitions. So Industry 4, automation of business decisions. Industry 3, automation of industrial processes. Industry 4, automation of business decisions, because TCP allowed us to combine together the OT and IT networks, and we could basically take the data that was being generated by all these smart things and put it in one place so that we could automate business decisions. A business decision would be like changing the schedule or changing the lot that we're going to run as a raw material on some asset. Or a business decision would be deciding to run a work order on this asset, not this asset, because the OEE, the historical OEE on asset A running that master part ID is 11% lower than the historical OEE of running that part on this other asset. Okay, that's automating business decisions. The fifth industrial revolution, now after post-GPT, is the convergence of human and artificial intelligence. Speeding up the decision loop. So taking data and converting that into a decision, whether it's an operational, process, or business decision, using human and artificial intelligence together. Basically, humans defining personas and agents, and having agents make decisions at the speed of light. So rather think of an AI agent as the descendant of the PID loop. So the PID loop is doing reasoning, but it's doing very, very, very basic reasoning on one algorithm. And an AI agent is doing incredibly complex, layered reasoning on many, on infinite numbers of algorithms. And in fact, having the ability to create its own algorithm. All right. So if what we want to do is use AI agents to speed up this data to decision process, I'm going to give you an example. When I saw Datos Tech, this is just 2 months after I'd gone to Europe and I had been advising a glass company. So And I asked them all the obvious questions, like, you do 50 million a year, why don't you do 100 million? And they're like, oh, well, kind of everyone always wants to blame the market. They're always like, well, the demand for our products is dropping. Well, that's not true. The demand of your product will go up if the cost of your product goes down. Okay, so the what they're doing is looking at alternatives for your product because the cost of your product is too high. That's almost invariably what they have. So one of the things that we deduced in this glass manufacturer was that if they wanted things to be cheaper, they had to increase yield and reduce waste. Okay, and they had to reduce energy consumption. They had to be more optimal about the way that they were melting their glass and keeping the glass warm throughout the process. And everything funneled down to basically two problems. Number one, we either end up with bubbles in the glass, or we end up with cracks. And so the question was, how do we get rid of the bubbles and the cracks? And the answer is in the forming line, we have to better control the heat in the forming line while the glass is being formed. Why is it we don't do that? And they say, well, you would need the technology you would need would be too expensive. It'd have to be able to read these you'd have to have state-of-the-art temperature sensors that were taking measurements 10,000 times a second, 100,000 times a second. You'd have to pick up small trends at the 5 millisecond level. Then you would have to be able to transmit that to an analytics engine at that speed. An analytics engine would have to be able to decipher the data, make the decision, and send it back to the control loop, all within the window of 50 milliseconds or less in order to be able to control that process loop. And so at the time, before I saw Datos, I was like, you know what, I can't fix that problem because they're not going to spend millions of dollars on the hardware I got to put there. The software didn't exist yet. And then I get introduced to you guys. And it opened up this entire world of all these use cases that are now relevant again because your technology exists. Right. All right. So that's the frame. Why, if you guys want to know why I'm excited about it, I literally had a specific use case. All right. So let's ask this question. Let's frame the real-time discussion. So if our problem is we now have fast data, but we have slow decisions, okay? The question is, why is having a telemetry stream, so that's what unified namespace is. It's the telemetry stream.
Yep.
Why is having the telemetry stream not enough? Like, a stream isn't intelligence, right? The intelligence comes from analyzing the data that's on a stream, right? That's the knowledge.
Yep.
What was the gap that you saw? Because you guys decided to take this, which was going to be for Vision Pro, and move it to industry. What was the gap that you specifically saw that said, hey, industry has the gap and we can fill it? Why did you see it and the industry didn't? Why is it, Ken, you guys saw that gap was there and the industry was just accepting they couldn't solve the problem?
Okay, so the multiple problems that need to be taken care of. One, I have to manage to keep up with however fast the stream is, right? So 3 million, 5 million, whatever. If I drop a message, I'm screwed. But in addition, it's encoded, and that's a problem, right? So it's encoded, and so when I first looked at Sparkplug and I got an actual I thought, oh my God, I'm back at the mainframe. It looks exactly like it.
No secret that you and Arlen are from the same.
We
same
are
generation.
Yeah, right. And I think that you got to convert it. You got to convert it, and you have to convert it as fast as possible. So decode, normalize, and convert.
So if the problem then over the last 12 to 14 years, we've been getting data off the floor as fast as we can. Okay. Well, faster and faster and faster. You know, originally it was 5 seconds. We were pulling it every 5 seconds. Now we're down to 500 milliseconds, and we're accepting 500 milliseconds, right? And we bring the data off the floor faster than ever. But where are we putting it? Well, first off, we're putting it in a unified namespace on each event, on each event cycle. So in a UNS, we're seeing right now the last 500 milliseconds, the last second, whatever it is.
Yeah.
And then what are we doing? There's a consumer that's subscribing to all those messages and dropping it into a historian or a data lake. Like we're either buffering it and streaming it into a data lake, or we are immediately inserting it into a historian. And then immediately...
Well, and Walker, it's all getting stored as messages. Right?
Correct. Getting stored as messages, which means the decision window now slows down. The decision window doesn't go at the speed of the event. It slows down because of where we're storing it.
Right.
And how we're storing it. Right. This is why arrow to parquet matters. This is why using Rust matters. This is why arrow to parquet matters. This is why in memory matters. Right. So
this is one of those situations where you cannot be too fast. You can't be too fast. It's not possible. Over the next 5 years, we're going to see a multiplication of the number of messages, the complexity of the messages. All of that's going to get driven by the agents who are going to want to do more and more and more, multi-step or not multi-step or complicated. And I need more. And so I'm going to be asking the control engineers, hey, can you make that device put out a bigger payload?
Get this. You want to hear something crazy, Ken? Yeah. And the speed of agents is the one that's driving that.
Yeah.
Okay. A year and a half ago, I did a use case where I had a Claude agent. I tested Claude, ChatGPT, and Gemini, and I had all of them analyze a UNS and then build a dashboard in React for an operator based on a JSON definition. I said, here's the definition of all the components that got to be on the window and what they get wired to in the UNS. And I said, I want you to build this in native React for me. Okay. Across the board, they all took more than 2 minutes to build the dashboard. So it was, they were using 200 different data points and they were showing time series. And I mean, it was fairly complex. Claude was by far the fastest. Maybe 30 seconds faster than GPT, which was the second fastest. Today, I did the exact same benchmark this morning in preparation for this because I had an idea. Claude Opus 4.7 built the dashboard in 22 seconds. Yeah. So in 18 months, we went from over 2 minutes to 22 seconds, exact same dashboard, exact same definition. So what does that mean? That means 18 months from now, we're going to be at 1 second for the generation of that dashboard. That's what it means. Okay. Now, clearly compute is what's changing that, right? They're just speeding up, they're just, by throwing in data centers, they're able to compute, because I've seen some of the government benchmarks. By the way, anybody who's wondering, if you want to know who gets the best AI in the world, it's the government. It's 100 times faster than ours. 100 times. So anything you do in your Claude desktop right now, in any of the Claude desktops for government, it's 100 times faster. So agents are driving the need for faster and faster and faster. And here's the crazy thing I was thinking about, Ken. If I can publish 1 million messages, I can do. You did 3 million in 2.3 milliseconds and 5 total, whatever. That means I could, in theory, use all of the messages over just a 1 second window to create a mini historian in memory for the agent to do analysis on.
Sure. Now we also have rolling windows that are implemented in the data server. The path we went down, we were at March of 25, we were at 65 milliseconds query time. We're now at, I don't know, 2 or 3. Luke and his team know that I want to be in microseconds. And I think there's just the appetite for speed from a swarm of agents, let's say, is going to be pretty high. And so you're going to see, and I think certainly Claude and ChatGPT, they are very aware that performance is going to matter here.
So for basically everyone here is watching this. They run historians, time series databases, right?
Sure.
Most of them are using data lakes, and some, although a lot of people are moving away from the data lake, but everyone's still moving towards time series. what's interesting is a lot of people are doing their own time series in Postgres now, which is something that cracks me up. But anyway, why isn't that enough? Like from your perspective, like if they're using that data for decisions, why isn't that enough? I mean, I know what it is, but I want to hear it from you guys. What to the audience? What is the message that we have to send to them? Why taking the stream and dropping it in a historian and then analyzing it there isn't sufficient for all your use cases?
You're now hours later. That's not good enough.
At a minimum, minutes.
Right. Yeah. So you, and I got to get somebody to invite me to go on a tour of their factory, because other than Tesla's factory in Fremont, I've never been in a big complicated factory. There's a lot going on really quickly, and the opportunity for event cascades is enormous. Yeah, and so
it's one of the number one issues, especially in continuous processes.
Right. And so you need to be on top of things, and on top of things doesn't mean 2 hours later. On top of things means,
And at the end of the day, we have two types of control, supervisory control windows. You have the process window. That is, we need the PLC to run at a certain speed in order to control the process. The decision from input to processing to output has to happen within a certain window, and that is always going to be the cycle time of the processor. That's where you go and look at that benchmark inside of a PLC. That is just one subset of all the decisions we make in a plant. And what we are talking about is DADOS's technology, Flow and Lightning, can become the pipeline to make all of our sneaker net decisions, all the other decisions we make in the plant, operate at the speed of our PLCs.
Right. That's right.
That's the implication. And how are you and guess what? Human beings are no longer the limiting factor, because we have agents to help us. So
and the agents want instant. They don't want
they want millisecond.
Yes, that's right.
They want millisecond.
Yeah. And I think that if you look at how this is going to go, it'll start and then it'll pick up, because I think the benefits of this, the payoff is going to be very large.
Well, yeah, and yeah, I mean, make no mistake about it. We are talking about technology that most people are not going to be able to appreciate for another year. Like right now, the vast majority of the market will not be able to appreciate this conversation for another year. But more and more, everyone is running into the problem of, I can't get my data fast enough for my agent to process it. Like, the issue is not, I don't have access to the data. I can't get it fast enough for the agent. So everyone's trying to make these hooks where, they have the agent hooked into a UNS so they can see semantic hierarchy and real-time state. But from real-time state, they basically see a condition. And from that condition, the agent then goes, I need to go hit all these other tools back in this database, back in this historian, to try and retrieve the data I need to do the analysis. We have to engineer out that process. And what do you need? You basically go ahead.
That's what our rolling windows are for, right? So you hold not just single UNS state in memory. You hold the last 5 minutes, the last 10 minutes, the last half hour in memory.
Last day.
Yeah, and that can grow to whatever memory space you have.
Correct.
So
any log might be part of the answer to that.
Correct. Yeah. So any log, so what I say is the AnyLog technology and DADOS's technology combined together closes a massive gap in Industry 4. Right. Yeah. First off, AnyLog replaces the connect, collect, store layer. It just basically becomes the API that creates virtual unified namespace. So instead of having to extract, transform, and load it into a unified namespace, you're running the clients at all the data sources, and AnyLog creates the plane through which you create a virtual unified. To the user, you don't know, you're not talking to a broker. You're looking at something that is a broker, or it is a database, except it doesn't exist. It's virtual. when you run the query or you run the subscription, it's pulling the message directly from the device, and it just looks like it's in a central place, but it's not. It's virtualized that process. That's why AnyLog is different. It matters. The reason DADOS matters is that we're changing the threshold of what we think of as real time from 1 second or 500 milliseconds to 2 milliseconds for millions and millions of messages. So that means that from 2 milliseconds to the 500 millisecond window, I now have history over that time. That's not a real-time event. That is a series. That's a series of millions and millions and millions of events.
Let's not have the agent kick off based on the one data point from the UNS. Let's have the agent kick off based on the last 20 data points of that sensor starting to go wrong rather than hitting
Correct. And so now it's not just one data. It's not one value. It is one value in the context of many, many, many values so imagine in a real-time moment, instead of getting value in 500 milliseconds, instead of getting value timestamp, what we're actually getting is 300 data points. We're getting what it was at the row 0 all the way to row 299. Imagine how valuable that is to an agent to give you a more accurate analysis of the current state of your data. That, for those of you who are struggling, maybe, I don't know if anyone's struggling to see the value, but I do know that some people are like, I can't connect why this is important yet. Why do I need to care about faster than 500 milliseconds? Or why do I need to care about faster than 1 second? And the answer is because the agent cares. You may not care, you personally, because you're not processing. By the time you even think about the data point that changes once a second, you forgot what the last value is. The agent can process so much more than you, and the agent is your tool, right?
He's working for you. He's working for you.
Correct. All right, so real quick, just so we can explain it again, DADOS Flow, Lightning Plus, and Lightning Plus the API. Luke, explain those again, how they work, okay, and how they work together, because at the end of the day, that's DADOS tech.
Yeah. So Flow subscribes to the broker, to the existing infrastructure, takes the messages and translates them into the analytics format, columnar data, rows and columns, and sends that to Lightning Plus. Lightning Plus is the data server, and it holds the UNS state, but it also holds the UNS state going back for rolling windows, and however big your memory space is. And it's going to serve your queries, but your agentic queries as well, full SQL engine, so that you or your agent can on the fly make a change instead of just caching things. Right. And then the API on the other end is, and it, like I said earlier, it's an API wrapped in a library, so that we can make that transmission from the server to your agent as fast as possible as well.
I mean, no question. I mean, one of the things I want to, in the video, I'm shooting part 2 of this. Why does this matter? And there will be a section in that video when I'm going to be using an agent in that video, and I'm going to be asking that agent to do a complete operational analysis. Okay. And that operational analysis is at a very, it's at a high latency, right? It's not important that it takes the agent 30 seconds to analyze the entire plan. However, one of the things I asked the agent to do is show me places where I could extend my data infrastructure to optimize my operation. And the agent spits out basically a report and says, you should create these user edge relationships, and then you should add these topics to your namespace. And then you need an agent to monitor those relationships and these triggers in the namespace. This is where DADOS comes in, because now you want the agent to respond as fast as humanly possible. And that means it has to receive the data as fast as humanly possible. And this is where DADOS comes in. And I'll illustrate it in the video later this week. Okay. Let me ask. Yeah, go ahead, Ken.
No, I'm
okay. Let me ask you this question. So if someone is listening, because a lot of people get introduced to Datos, or this new concept of real time, the truth. By the way, no one would have ever argued that real time prior to this podcast was, 3 million messages every 2.3 milliseconds. Okay. To us, one message every 500 milliseconds is real time. And for some people, it's 5 seconds. And in oil and gas, it's once a minute. Real time to oil and gas is once a minute. Because they're used to 15 minutes every hour, once every 24 hours. The truth is that real time is as fast as you can possibly get it. And what Datos has changed,
and as much of it as you can possibly get.
Right. What Datos has changed is speed and volume. What speed and volume does for our definition of real time. And the more real time we are, the faster we can make the decision. And now that we have agents, we're no longer the limiting factor. Our limitation, our ability to consume, process, and act is no longer the limiting factor.
Right.
Agents can consume, process, and act way much, much faster than we can. Right. So if someone's listening, okay, and they're thinking, this might be the missing layer, this might be the missing piece. What is the step they need to take in order to determine that it is? Like, if this conversation is,
we have a free trial. It's a 7-day free trial. It's renewable. So if you want to try it, you can go to 40 solutions or 40 solutions.
40 solutions. Yes.
And download it there. You can also download it from our website. Our idea is that we'd like to have thousands of customers. Right? This isn't go sell something really big to somebody really big. It's sell this to everybody. And so we'd love for you to try it.
If we wanted to do a problem solvers where we had a use case and we're like, hey, we're going to use Datos for a specific use case. And we're going to, and that problem solvers webinar or we don't call them webinars, but they're problem solvers podcast, basically. The reason we call it problem solvers is because we share our screen. In a podcast, we don't, so that people on Apple's podcasts aren't missing anything. If we wanted to do that and we basically plug flow into an existing broker, consume, and we wire everything up, and then we show Datos in a use case, would you guys do that?
Sure, absolutely.
100%.
All right.
And Luke volunteered to do this a month ago.
Okay. Good. All right. So Luke, let me ask you this though: for those, if people go ahead and download, what are the couple of things that everyone should know if they go download this and at 40solutions.com and try it? What's the thing? What are the couple of things you want everyone, the quick heads ups? Hey, if you're going to kick the tires, know this, and this.
Download it. It's a Docker Compose deployment. So download it, load the images in, run the Docker Compose. There's a quick start in the download to help you out there. And then what it'll do is it'll guide you into a GUI to put your license key in, which you can get on 40 Solutions as well. And then from there, connect to your broker, and it's going to kick you over to the reflection dashboard, which is the GUI. Some of you will have seen at Prove It. And it'll start showing your data right as soon as you connect. And then, that'll get you into it and confirm that everything's working there. And then there's an additional download as well for the Python API library API connector as well. And you can connect and get started on the bespoke problem as well.
So one of the things that's very, very interesting about this, unlike any other data product I've ever built, the Sparkplug message stream will populate Lightning Plus. Right. So I had a conversation with Arlen Nipper about a month ago where he was explaining to me that when he designed Sparkplug, he designed it so that it was a self-contained representation of that event with all of the parts of it that you could load, and he expected that agents were going to eat it up. And
All right. So a couple of questions. Well, I'm going to answer a question somebody texted me. So, hey, why did you choose? Why you said you don't partner with companies? Why did you change your mind? Okay, what happened? I'm going to give you. I'll give you the generic answer, and then I'm going to give you the specific answer around Datos. The generic answer is that we're in an age right now where what we think of as software, the software development lifecycle, the product lifecycle management of software, how we go to market with software, what it is the market is going to pay for and what they're not going to pay for, all of that's changing. We're in an era right now where all of that is changing. So the future of software is if you're a software vendor and you are not writing software in mind that the toolkit we're building here is going to have to also work with the toolkit they built themselves, because everyone's building their own tools. If you don't have that mindset, then what you're doing is creating a product that's going to live on an island all by itself. Okay? The market is shifting, and I can help software companies make sure that they're developing their products in the ways that the end users are going to get the most out of them. So that's the generic answer. It's I have a unique insight into the industrial market, and I can advise them on where the market's going. And I ultimately made the decision through a series of conversations with other people I really trust who were like, hey, this is where you belong right now. Okay, so that's a generic answer. Why did I pick Datos and why did I pick Anylog? Like, why didn't I pick one of the other 20 companies that were asking me? And the answer at the end of the day, the answer to both came down to three things. Number one, they both had the right architecture. Okay, number two, they both have the right teams. And number three, the timing was perfect for both. Datos came along in Industry 4 exactly when it needed to come along, like just when the market's ready for it. In fact, just slightly ahead of when the market's ready. So there is time to perfect it for when the market is ready. And the same thing with Anylog. So that's my answer there. Okay, to answer your question. All right, real quick, I'm going to rapid fire with you, Luke. Can Datos read plain JSON from an existing MQTT UNS and query the rolling comparisons like two furnace zone temperatures with delta and slope?
Yes. The raw JSON is going to be slightly slower than the Spark plug just because of the packaging and the data structure. But yes, we did the raw JSON at Prove It on Enterprise A. Enterprise A didn't have any Spark plug, and we were loading it there. So yes.
Is Lightning Plus API SQL based, REST JSON based, or a custom query DSL?
SQL.
Okay.
So it's a I've been talking about it's a Python library. So you it does the transport layer for you, but you're querying with SQL.
Can Datos also bootstrap state from a historical database data, or does it only build state from the live MQTT messages? This is one of the first questions I asked Luke. I was like, is a broker the only ingress? Was the question.
No, so we can upload independent data sources into the data server, and then we're working on a way to then be able to live in like one query get the historian data and the live data in the one query. Right now it would be two queries, but you can load it into the in-memory database and then have it at the same speeds. You just have to make a second query. And we're going to fix that.
Great. And well, also, and your roadmap is really going to be driven by user feedback.
Oh, 100%.
Absolutely.
You guys are right.
Yeah.
All right, here. Can this be described as an integration of LLMs, agentic frameworks, tool calling, and RAG, retrieval augmented generation? So I'll answer. The answer is no. It can't be described that way. What it can be described as is what you described there. It needs Datos needs Datos' technology in order to get the most out for the operator, for the end user. So you're using LLMs, agentic frameworks, tool calling, and RAG to do analysis, right? To do advanced reasoning on data. In order for your agents to get the most out of that data, you need some type of technology like DADOS's tech, which will make it possible for the agent to have access to the context it needs at the speed it needs it. Right now, the agent is limited to a much slower context. We have a finite size of the context window, but the issue is how old is the data in the window is the issue. DADOS is speeding up that window. What we are accepting as real time is changing from 5 seconds 10 years ago to 1 second 5 years ago to 500 milliseconds now to millions of messages every 3 milliseconds. And when you go, why do I need that? The answer is you don't. Your agent does. Your agent needs that speed. All right. Is there a plan to ingest data from other protocols besides MQTT? I mean, this is a follow-up to the last question.
Yes, I had a lot of awesome conversations with people at Prove It. This is another one where we are absolutely going to do it.
DNP3 is one that I absolutely like. DADOS would have a huge impact on power distribution if you have a DNP3 connector.
Yeah, we 100% want to do other connectors. It's I'm losing connection. It's going to be driven by customer requests. But 100% we plan on doing other connectors.
All right, so go ahead, Ken. You got something?
I think that that's going to get customer driven, right? Somebody's going to show up, like the guys from the message broker. Hey, can you do millions, tens of millions of messages a second? The protocols, I'm not going to say that they're easy, but they're very doable if you have access to the protocol while you're trying to do the development, if you know what I mean. I've done a lot of network stuff.
Yeah, let's put this problem in the context of something everyone's familiar with. Last year, not this year at Prove It, but last year. This will be our last story. And then I got one question for both of you. HiveMQ announced Pulse and did an absolute masterclass in how to launch a new product. However, they announced it before it was production ready. So in a very controlled application, Pulse was able to perform at a super high level. What could Pulse do? Pulse could do very advanced data transformations and data analytics or transformations or on a message stream. Okay. You want to know why Pulse didn't get released until 9 months later instead of like 1 month later? Because when they tried to do it at scale, when they said, here's what our brokers can do at scale, our brokers can do this many messages at this speed. And then they tried to bolt Pulse onto that. Pulse could not process the messages at the speed that the broker could.
Right.
So if your expectation was, I want to be able to do this in-stream data transformation or analysis, and I expect Pulse to perform at the same rate my broker does, HiveMQ couldn't get Pulse to perform at that level. And so they had to go back to the drawing board to make it work. That is a scenario that more and more and more, the scenario where we need to be able to process these messages as fast as humanly possible is becoming more and more important. So for all of you who are pissed off why Pulse took 9 months to get released, well, the truth is if DADOS wasn't developing the tech for Apple and they had been developing it for HiveMQ, no one would ever fucking know that it didn't work. The DADOS's tech would have been perfect for Pulse. It would have been a perfect marriage made in heaven. Okay, and I'm assuming HiveMQ is who you talked to, but I don't know that you did. But I know that they were developing the tech, and you guys would be the obvious solution to their problem. So to me, that's got to be who you guys are talking about. But anyway,
there's just a real natural tendency for technology organizations to not invent it here.
Yep.
We got it handled. We don't need any help from you.
Correct.
Okay.
Let me ask you guys this question. So since Prove It, you guys obviously got a lot of traction at Prove It. You had a lot of conversations. Okay. What is the number one piece of feedback you were given, or the most interesting piece of feedback? Like, what is something you've learned from those conversations at Prove It or post Prove It that you didn't know going in?
Luke, you go.
So as we've gone over, we came out of the data world, and so had no exposure to what the problems look like. And so I just had a really awesome time at Prove It, talking to people about, well, this is what we can do, and then talking to people about what their problems are, and the breadth of the problems and the different places people are, well, to use your words, in the digital transformation. So, you talk to people at Prove It. It was such a wide field of places people are in that journey. And,
right. You had Constantine from Euclidine doing a super advanced edge compute use case. Like, I know he came over and talked to you guys because you have people like Constantine doing these super massive, hyper advanced edge use cases, right? And then you've got people who are like, I just want to know which of my machines are running. Like, you
Right.
literally, the chasm is that far in our industry. Like,
Right.
it's that far.
I agree with that. Since Prove It, I keep getting surprised at how quickly things continue to advance forward. I'll just tell you straight up. When I walked in to Prove It, I had never heard of a knowledge graph, even though it's my initials. So but since then, I have become convinced that this is super important.
Mm-hmm.
And I believe what you're going to see is, well, one, it's not that I was really put off when I first saw it. I thought, what the hell is this? And then okay, let's take another look. Let's take another look. And about the fourth or fifth time, I go, oh, I get it. I get it. I can the agent can follow a chain all the way back to root cause.
Correct. And backtrack and move horizontally to another knowledge domain, grab some of the context from the knowledge domain, then go back to the root cause and use the context. There's no way to overstate the power of knowledge graphs. It
simplifies the research part of this. Correct. For the agent, also for the human being. I think human beings are going to like working with agents that know how to do this, because you're not just stuck. I got an alert. Now, what am I supposed to do? And I think as the agents evolve, that'll get better and better, and the worker experience will get better and better as well.
Well, I can tell you right now, one of the things I'm doing with Datos, here's a little insight. One of the things that I'm doing with Datos is I want to use Flow and Lightning and the API as the underlying layer that builds my knowledge graph. So right now, the limiting factor to drawing a knowledge graph, that is drawing a knowledge graph in a container or in an object, and being able to see it as either radial or force or hierarchical, is the retrieval mechanism from the structure, which is ultimately a JSON, but it's the retrieval mechanism from the store to the graph at the rate the data updates. Yeah. Datos will make it look like we'll draw the graph. We'll give it the pipeline to draw the graph at the speed of light. Right now, really, really big graphs, they are herky-jerky. They have a lot of latency. They lag a lot. And the reason why is the underlying information data plane is too slow.
Right.
Okay. And so what I'm working on is taking Datos and using it as the data pipe that takes the structure that is stored, in this case will be in memory coming from a broker, and getting it as quickly as possible to the renderer that draws it on the graph. By the way, it's kind of full circle. This is originally what your technology was going to do for Vision Pro. So it's kind of crazy.
Maybe we'll have to have a little side project where we show
Well, it turns out that any technology really well done will find a home.
Yes.
I've had occur more than once in my career where you go, okay, this market's dead, and then all of a sudden another door opens.
I just want to say something real quick, and we'll take it home about the knowledge graph thing. So everybody knows Jeff Noonan from Rise, right? Jeff Noonan, he's a world-class solutions architect, one of the most brilliant guys I've ever talked to. I have the utmost respect for Jeff. Super gifted. And you guys may remember on a podcast probably in 2019, somebody was asking me about their technology, and it was originally, their platform wasn't called Rise. It was called something else. I can't remember the name of it. And you guys may remember I said, I love the tech under the hood. Libre. It was originally called Libre. Thank you, Josh. So I said, I love the tech under the hood. Okay. And what I was saying was, I love how they're using GraphQL and knowledge graphs for the data plane. Okay. But I didn't say that publicly. I just said, I love the tech under the hood. The market was not ready for knowledge graphs 5 years ago. The percentage of the market that was ready was a fraction. If you started talking about knowledge graphs and drawing radial graphs of relationships of businesses 6 years ago, no one would be able to draw a line between what was on the screen and the problem they have in their plant. But now a massive chunk of the market, because of the explosion of unified namespace, the adoption of unified namespace, this massive chunk of the market now can draw a straight line between what a knowledge graph can do and the problem they have on their plant floor they need to solve because of how the market has evolved.
The UNS gives just the perfect seed to start the knowledge graph.
Correct.
Start with your UNS hierarchy and then just expand it to infinity.
Correct. You start with that 2D relationship rendered in 3D, and then create the 3D relationships. That is the relationships outside of the hierarchy. So right now in a hierarchy, you can only create a relationship to parent, child, or sibling, right? That's two-dimensional. It only goes up or down and sideways, but sideways is your plane. The third dimension is being able to go from your plane to another plane. A relationship from my plane to another plane creates the third dimension. That's what knowledge graphs do. I can take a temperature. I can take a heat number from a billet that comes off of a furnace in the melt shop, and I can connect it to the heat number in shipping. And they are not in the same hierarchy. They are not. There is no direct relationship between them. But I can say the heat number from the furnace, the heat number in the shipping, is a descendant of the heat number in the furnace. That is a user edge relationship that knowledge graphs give you. And if you give an agent that context, an agent can now use that connection to if I say something like, what is why do I have this quality problem with these billets in shipping? They can connect the billets in the shipping to the heat number on the furnace, and then they can look at things like, what was the metallurgy of the billet? Because the metallurgy doesn't live in shipping, it lives where it was created. Knowledge graphs give you the ability to connect that stuff together. And the point is, the market is ready for that. And because the market is ready for that, the market needs technologies like Anylog and Datos. Like what we thought of as real time 5 years ago is no longer sufficient. It's no longer sufficient. Real time has to be something like millions of messages every 2 milliseconds. 5 years ago, we would have said that's ridiculous. No one needs that. No one needs that speed. And if you do, you can use a PLC with field bus. But it's changed. And that's what this whole podcast is about. All right, with that, thank you guys for, we went just slightly over. Just a quick thing. I'm going to be shooting part 2 of why does this all matter, and a lot of what I just talked about here I'm going to be illustrating in that video. I'm probably going to be shooting it later this afternoon, so it'll probably go up tomorrow, maybe Friday. But with that, Ken Gardner, Luke Gardner, we'll be seeing a lot more of you guys. We'll do that problem solvers here in the next month or so. Thank you for joining us.
Yeah,
Appreciate you guys.
Yeah.
And for those of you who have stuck with us for the full hour and 19 minutes, thank you. I appreciate you. Like, subscribe, comment down below, and we'll see you fools in the next one.
Okay, cool.